Hello, welcome to the control system technical aptitude problem. In this lecture we will be giving out few problems in state space analysis, working out the detailed solution. Welcome to the lecture. Okay, this is the first problem. The state equation is given, right? We are asking find the transfer function. First thing, from the state equation you have to write things in the a matrix model, right? That is your x is equal to x dot is equal to a into x plus b into u. This is your state equation. Okay, what is x dot? X dot is nothing but your x1 dot and x2 dot. If you observe, writing in matrix form, this becomes 2 minus 1, 2 minus 1, and for u it is 3. For the second row, this is x1 is not there, so I put 0 in place of x1. So x2 is there, so x2 coefficient is minus 4. Try to write things in matrix form, thereby you will get a, b and c. Okay, c you can obtain from the output equation, that is your output y is equal to c into x. Okay, fine. So x is x1, x2. Okay, right. How to write these equations I have given in a separate video lecture, state space analysis part 1, part 2 and part 3 in the channel Fundamentals Learner. You can refer those videos. Okay. Now once you found out that a, b and c, to find the transfer function I need to use this relation, that is c into si minus a inverse into b. This derivation is given in the video lecture. Please refer the video lecture. So here we are taking a. So this is your a, b, again I am repeating a, b and c. First you calculate si minus a. This is your si. I is an identity matrix. This is your a. So si minus a. Inverse means I have to take adjoint of si minus a and divided by the determinant of si minus a. Okay. So we take an adjoint of si minus a, that is we change the primary diagonal elements and we change the sign of the secondary diagonal. Okay, opposite diagonal we change the sign of it, so it becomes, we are changing these things. Then we are going for si minus a inverse into b. What is b? b is 3 into 3 minus 1. Then matrix multiplication, multiply the 2 cross 2 matrix with 2 cross 1 matrix, we get this answer. Okay. Now we need c into si minus a inverse b. So see what is c? c is 3 comma 3 minus 2, and we already found out si minus a inverse b here, right? The answer is here. Bring it here. Now we multiply. Okay, what is si minus a determinant? Take the determinant of si minus a, we get this term. Okay, so the answer is, on solving we get 11s plus 35 divided by s minus 2 into s plus 4. So the option is s plus 4, okay, minus 35, right? So the option A is the correct one. Okay, option A. Now we move to the next problem. Okay, the same problem. Okay, fine. Now the system matrix is given. They are asking to find state transition matrix. Okay, what is state transition matrix? Is si minus a inverse I have to find, then I have to take inverse Laplace transform. Okay, what is si minus a? Already we know how to find si minus a. I am going to take inverse. Okay, so it becomes like going to for 2 cross 2 it's easy to find a adjoint matrix. You interchange these two elements, then put opposite sign, then divide by the magnitude. Okay, for s plus 1 0 minus 1 s plus a, the magnitude is s plus 1 whole square. Then divide each term by the denominator, it becomes we can get this expression. Then take inverse Laplace transform ILT. What is inverse Laplace transform of 1 by s plus a e power minus t? For 0 it is 0, t into e power minus t it is for 1 by s plus 1 whole square it is t into e power minus t. For 1 by s plus 1 it is e power minus t. So the option, which option is correct? On seeing, yeah, option B is the correct option. Okay, right. Now we move to the next problem. The system matrix is given. They are asking whether the system is stable or not, right? So thing is, we have to first, in a control system, we will find a characteristic equation. By solving the characteristic equation, we can say this comment on system stability. In this equation, how to find the characteristic equation is just to take the determinant of Si minus A inverse, Si minus A. Okay, and the root should be should have negative real part. That should be the left half of the S plane. So what is I am forming Si minus A. This is my Si minus A matrix. Okay, I have formed it. Then I am taking determinant 3 cross 3. I can easily take the determinant. I get this expression. So third order system. If you go for the poles, you will get the poles as minus 2, and minus 1. Okay, so all the poles are in the left half of the S plane. If you are unable to solve this, you can, if you are unable to solve the third order, you don't have the calculator, you can either go for route table, right? You can use route table also. You will get all the elements in the first column as positive. Because in some competitive exams they won't give a calculator, so you have to use the help. You get the help from the route table. Okay. Now we move to the next problem. Okay. In this problem, what they are given is they are asking zero input response, right? Zero input response means they are saying that, so this is the state equation, x dot equal to a into x plus b into u, input is 0. Okay, so just in deriving, you can observe the derivation, determinant, the differentiation becomes s into x of s minus initial condition. Zero input response means only initial condition is present, right? For a into x, it becomes a into capital X, a x of s, right? We are taking the Laplace transform. This is your Laplace transform, right? Bring capital X of s term to the left side, take x of s, bring this term Si minus A to the right side, becomes inverse, right? So this is the expression you can use to find the response, right? That's a zero input response. Okay, so what is Si minus A? I have found out Si minus A. See, what is Si minus A? This is your Si minus A. This is Si minus A. Then I have to take inverse. So what I do? I will change the primary diagonal element and change the sign of the secondary diagonal. Okay. Then I divide everything by the denominator. Okay. So I got Si minus A inverse. My thing is I need to do with, I have to find Si minus A into x of 0. What is x of 0? Initial condition. It's clearly given 1 and 0. You multiply first row into first column, second row into first column, you get these values, right? Now you take inverse Laplace transform. For 1 by s minus 1, inverse Laplace transform is e power t. For 1 by s minus 1 whole square, it is t into e power t. So which option is correct? Option D is the correct option. Option D. This is the correct one. Next, it's a problem where A is given. They are asking state transition matrix. Okay. So how to find a state transition matrix? Just you have to take Si minus A inverse. What is Si minus A? This is the expression I get. How to take an inverse? It becomes like this is like take an adjoint of Si minus A divided by the magnitude of that. Divide each element by this term. You take inverse Laplace transform. You will get s by s square plus 1 is cos t. 1 by s square plus 1 is sin t. Okay. Which option is correct? It's like cos is positive. Yes, option A is the correct option. Right. Let me move to the next problem. See, the question is under what condition the system is becoming controllable. So for system to be controllable, we have to find the matrix S. Right. We have to find the matrix S. Matrix S, and to find the matrix X, that rank of that matrix should be equal to n. If it is n, I can say the system is controllable, right? What is n in this problem? The n in this problem is the A matrix, n cross n. Okay, that is your 3 cross 3. So the rank of S term rank of this matrix should be equal to, rank should be equal to 3. Then only I can say the system is controllable. But in this problem, they have already said it is controllable. They are asking under what condition. So B, we know what is B. We have to find what is A into B. We got A, this is your A, this is your B term. So you multiply, we get this expression. Then A square B is nothing but A into AB. We already found AB. That's here. multiply with A, we get this term. So form the matrix S, right? This is your B, this is your AB, this is your A square B. Now take the determinant. On taking the determinant, well, they should not be equal to 0. Then only we get the rank is equal to, then only we get rank 3. Okay, so on taking the determinant, it becomes A1, A2 square is equal to 0. Should not be equal to 0. For that, A1 should not be equal to 0, A2 should not be equal to 0. Okay, if it is 0, what happens? The rank becomes 2. It becomes uncontrollable. For the system to be controllable, the determinant of S should be not equal to 0. For not equal to 0, A1 should not be equal to 0, A2 should not be equal to 0. A3 can be 0. So the option is option D. Now, they are given a system model is given. They are asking whether the system is state controllable and state observable, right? So look at the A is given, B is given, this is your C. For state controllable, it is B into AB. First to find out AB, A into B, get this. So form the matrix S, A and AB. Find determinant is not equal to 0, so the rank is 2. So we know what is N. N is 2 cross 2. Since they are equal, so it is controllable. For state observable, it should be C transpose, A transpose, C transpose. What is A transpose, C transpose? How to take a transpose? Change the rows into column of A, right? First row will become first column, second row will become second column. C transpose, similarly you change the rows into column of C. This is your C, right? So I can write this is your C, this is your A, this is your B matrix. Okay. Now fill the matrix S naught. So C transpose, A transpose, C transpose. Now you take determinant, we get the answer as 4, that is not equal to 0. So the rank is 2, which is equal to N. So the system is absolutely observable. So it's both controllable and observable. Okay. Then another problem, they are given a state space model. In this, they are asking whether it is controllable or observable. Okay. Right. Okay. So, right. Find out A, find out B matrix, find out C matrix, find out the D. Right. For the system to be controllable, B, A, B, we get this. Right. Since rank is 2. Here, it's not equal to 0. Not equal to 0. Since we are dealing with observability, it should rank should be is equal to N. Okay. Here the N is 2 cross 2 because A is a 2 cross 2 matrix, so N is 2, so it is observable. So this system is also completely controllable and observable, right? How to find A and B? You please visit the lecture state space analysis part 1, part 2, part 3, then come into these problems. You'll get a very good idea on how to solve these problems, right? You have to, this expression is given in equation form, try to convert in matrix form, right? With the standard form is x dot equal to A into X plus B into U. Find out A and B. Similarly, Y is equal to C into X plus D into U, right? Where X is the state variables, Y is the output, U is the input. These things are clearly explained in the lecture. Okay. Next. Right. Now look at this problem. In this, the equation is given. They are asking what is A. But here some caution is required. Here I have mentioned the di by dt, dEc by dt. Here it is given Ec and I. If I write in generalized form, I cannot write x dot equal to A into X because order is changing. But if the problem is given like this, I can proceed with the answer. There is nothing wrong in it. Okay. Right. First thing, what are the state variables present is I and E. Inductor current is I, capacitor voltage is Ec. Then what I have to do? I have to find I dot of t and Ec of t. Okay. Right, first order differentiation. I have to write in terms of state variables and input. Input is E of t. Right. So first thing I am going to write KVL for this loop. It is minus Et I into R plus L into di by dt plus Ec. Okay. So keep di by dt in the left side, bring other term to the right side. Now we observe whether we are satisfying this condition. What condition? This condition, right? Observe whether this term is in terms of IT, EC of t and E of t. Yes, it's right. We have only I, EC of t and E. So this equation I can take for state equation. This equation I can take for state equation. Okay. Now I have to form another equation, that is your, what is the collector current? I equal to C dEC by dt. What is dEC by dt? Bring C to the left side denominator, it becomes 1 by C. Now think whether I am satisfying this expression. Yes, it is dEC by dt is equal to 1 by C I in terms of I. So these two equations are satisfying this condition, right? So I can write in the matrix form. This is equation 1, this is equation 2. In the matrix form, if I write, I will get A as minus 1 by L minus R by L 0 1 by C. Okay. Okay. Now they have given a transfer function. They are asking to find the system matrix. There are so many ways to find system matrix because it is not unique. But these sort of problems are some standard problems, right? I can say these are some standard problems. Standard problems, like in the sense when the numerator is not having S term, there is no zeros, that is a transfer function. As a transfer function is asked, what I have to do? I have to compare the standard form. Standard form is 1 by S cube plus A1 S square plus A2 S plus A cube. If it is in this form, this is the, I have given the derivation in the another lecture, right? State space analysis part 1. You can refer that video. Okay. So minus A3, minus A2, minus A1. If you compare with this problem, this is my A3, this is my A3, this is my A2, this is my A1. So fill those values, you get the option, right? Among this, which option is satisfying? I think option A is satisfying. So this is the correct option. Okay. Okay, this again repeating. Okay, fine. Now look at this blocks, right? Among this, which are the blocks which are not observable, right? Which are not, or first we will take about the controllable, right? Which are not controllable. Among the state variables, which state variables are not controllable? That is the question, right? State variables are not controllable. Okay, what are the state variables? State variables are x1, x2 and x3. Controllable means, the meaning is actually it is input controllable. Input controllable. Among x1, x2, x3, which is not controlled to the connected to the input x3, right? So x3 is not, x3 state variable is not controllable. Okay. Now we look at this diagram. Which among the state variable, which state variable is not observable? Which state variable is not observable? Okay, this is for this problem, right? This is for this problem. It is not observable. Observable means it is output observable. Keep in mind, observable means you should observe from the output. Control means you are controlled from the input. Output observable, right? If you look at it closely, output observable is y. If you say this x1 is connected to y and x3 is also connected to y, but this x2 is not at all connected to y. So we cannot observe, x2 is not observable. Okay, there are some tricky questions, right? Okay. Now look at this problem. In this, what is given is they are asking to find, this is a gate problem, right? They are asking 2020 question, 2020 engineering, electronics communication question paper. The input is given as first thing. First you have to identify what are the inputs. Input is I1 and I2. You can see the expression, right? This is the input vector. And what are the states? Capacitor voltage and I. Capacitor voltage and I are the state vectors, state variables. And what I have to do is, this is very important. They have to determine this term first. What I should do? Okay. Try to write dV by dt and di by dt in terms of state variables V and I and input. Okay. That is the state equation meaning, right? dV by dt, di by dt in terms of V and I I1 and I2. I have to write it this first, right? Okay. Let us assume this is node 1 and node 2. Node 1 voltage I am assuming as V1, right? So I can write applying Kirchhoff current law. I1 is equal to, this current is V1 by 2 plus I. Okay. Similarly, I can do, this is not required. Okay, fine. Now, what about the voltage across the inductor? Voltage across the inductor is V1, this potential is V. So this point is V. V1 minus V is the voltage across the inductor. We know what is the voltage across inductor. V1 minus V equal to L. Current through the inductor is di by dt. Now bring this V here, you substitute it. This is my, this expression I will be getting. I need to find out di by dt. Di by dt, bring 2 by L to that right side. I substitute the values of L. Now check whether I am satisfying this condition, right? So di by dt in terms of V is there, V is here, I and I1, I2 is not there, so I can put I2 as 0. Okay, so I can write I2 as 0 I2 plus 0 I2. Okay, now I find another equation. Okay, at node 2 I am applying Kirchhoff current law. Incoming current is I1, I plus I2. I and I2 are incoming. Outgoing currents are capacitor current and current through this. What is the current through 1 ohm? V, this voltage is V, so this voltage is also V, so V. Okay, so I plus I2 is equal to V by 1. That is the current through 1 ohm. What is the current in the capacitor? C dV by dt. So I need dV by dt, bring C to the right side. I get this expression. Substitute the values of C as 0.25. That is 1 by 4. I get this expression. Now check whether it is satisfying this condition. dV by dt I have written in terms of V. Yes, V is here. I is here. I2 is here, right? So I got second equation. Now to write things in matrix form, I get this answer. Okay, which equation is satisfying this? I think it was satisfied by the option A. Okay, right? It's very important. These steps are essentially important, right? Very important steps. So these introduction steps, because you have to be very clear what you are going to do, what is the input, what are the state variables, and how you are going to write. Then only you can form the equation. Okay, then order is important, right? Okay, then some simple questions like two resistor, one inductor, one capacitor. Number of state variables required in the state model. Number of state variable is equal to number of memory elements. One memory element is another memory element. So I need 2 state variables. Okay, and we know in the state space model, input is U, output is Y, states are represented by X. So it is U, Y and X. Option B is the correct one. The system matrix is 3 cross 3, right? Number of state variable is equal to 3. This should be n cross n, means number of state variable is n. Some easy questions, right? Okay. Then important, state variable analysis can be applied to time variant system. True. Okay. It is applicable for both time invariant and it is applicable for both system, time invariant and time variant system. It is applicable for both, right? But the transfer function is applicable only for time invariant system. Then this is important. State space model is unique. No, it is not unique, right? It is not unique. There are different state space model I can write, right? For a given system, there are different ways to write the state space model. Okay, that's it. Okay, I hope you enjoyed this video lecture. If you like the channel, please do subscribe the channel and comment in the comment section. Any doubts and clarification, put it in the comment section. I am very happy to help you. See you again in the next lecture. Thank you.